Scientists, are you ready for a virtual field trip? From sunny Los Angeles, let's go to the California Science Center with your hosts, Mariela and Monica, with a special appearance from
Rosemary Garista.
Let's go to the California Science Center.
Hi scientists, and welcome to our virtual field trips at the California Science Center. Before we get started, there are a few things we need to go over.
All virtual field trips will have a question of the day. And today's question is,
what happens when particles mix together?
Pause the video now to write down the question of the day in your notebooks. And don't forget to write down or draw things that you observe in the video to help you answer the question of the day.
all virtual field trips will also have a buzzword. Today's buzzword is
Mixture.
Anytime you hear this word, be sure to make check marks or tally marks somewhere in your notebook to keep track of how many times you hear the buzzword. Can you count them all?
Before I forget, there might be times we ask you to pause to think about a question. You'll see this sign and hear this sound to remind you to pause. Okay, scientists, I think we're ready to begin. Follow me. Hey, Mariela, what are you doing? Our scientists have arrived for our virtual field trip.
Yeah, I know. That's why I'm here. Aren't we talking about mixtures?
We are, but painting isn't quite what I had in mind. What does this have to do with what happens when we mix things together?
I'm glad you asked, Monica. As you can see here, I have 3 colors of paint. These 3 colors are known as the primary colors. Now, it could be really hard to make a whole painting just with 3 colors. So we can actually make mixtures to make more colors.
A mixture, that's right. I know about that. Scientists, a mixture is a material that is made up of 2 or more substances.
That's right, Monica. Now, let me show you how to make mixtures with paint. Okay, Monica, I'm going to make a new color by taking some of the blue paint and mixing it with some of the yellow. As I mix the 2 different colors, they create a mixture. Now I have green paint.
Oh, I see. You mixed the 2 to make a new color. Wait, aren't we talking about science? This feels like art.
You're right, Monica. This is art, but it's also still science. In science, we have 2 types of reactions when we make mixtures. We have physical reactions or chemical reactions. Mixing the paints is actually a physical reaction. That means we are changing how something looks, but the microscopic particles that make up this paint are still the same. As you can see here on my palette, I still have paint, just different colors.
Very clever, Mariela. I see how you made that connection. You were thinking about physical reactions. I, on the other hand, was thinking about chemical reactions. Can I show you what I had in mind?
Yeah, let's go.
Let's go. Okay, Mariela, this is what I had in mind. This experiment is something that people ask us to do all the time when they visit us here. Mariela, let's make slime.
Slime? I love slime.
Me too. And here at the California Science Center, we use 2 different types of chemicals to make our slime. We use polyvinyl alcohol and sodium borate.
Both of these are liquids, as you can see. But once we mix them together, they are no longer a liquid.
Whoa! This mixture is very different from the 2 original liquids you started with, Monica.
In this case, we are creating a chemical reaction. A chemical reaction can happen when you mix two or more substances together, and there is a change in particles that make them up, causing a new material to be formed. In the case of the slime, we took two liquids that linked chemically and made the slime.
See how stretchy it is? And a little more solid. It's something brand new.
Wow, that's so interesting. But do all chemical reactions look like this?
Great question, Mariela. Let me show you another example. Here we have polyurethane A and we have polyurethane B. Check them out. How would you describe them, scientists?
This one kind of looks like syrup.
Yeah, and this one looks like honey.
Even though they both look like syrup and honey, they're actually both chemicals.
Well, they both look pretty similar to each other. What do you think will happen with this mixture, scientists?
Now that you've made your predictions, let's find out what happens.
By mixing these two chemicals, they react. First, we see the color change. And as time passes, these two chemicals create a gas that forms bubbles that make the mixture grow. Check it out. Over time, this mixture hardens. This chemical reaction is used in insulating houses, to make puppets, and also to make boogie boards.
Okay, scientists, it's time to put your knowledge to the test. We're going to show you a few mixtures, and we want you to share if this is a physical or chemical reaction.
Remember, with a physical reaction, we will see our mixture change in appearance. But with a chemical reaction, we will notice a whole new substance.
Here are our first two materials. First, we have water. Is this a solid, liquid, or gas? Now we have food coloring. What state of matter is this? Before we mix them together, what do you think will happen? Let's take a look. What kind of reaction is this? This is a physical reaction. Notice how the food coloring just changed the color of the water. Here are our next materials. Ketchup. What state of matter is this? Now, baking soda. Maybe you've seen this in your kitchen. Is this a solid, liquid, or gas? What do you think will happen when we mix them together? Let's take a look. What kind of reaction is this? Did you guess chemical reaction? Yes, as you can see when we mix them together, they create a gas, and we can see them bubble. Now we have soda and sand. What state of matter are both of these things? Before we mix them together, what do you think is gonna happen? What kind of reaction was that? That's right. This is a physical reaction. Seems tricky, but the sand is making the soda do what it would do on its own, just faster.
Here are our final two materials. First, we have oil. Is this solid, liquid, or gas? And water. Okay, scientists, make your final prediction. Here we go.
Whoa, is this a mixture?
I don't know. I can still see both liquids. What kind of reaction is this?
What if we shake it more?
I think I know someone who could help us figure this out. Come on.
Hi scientists, my name is Rosemary and I work at the Education Department here at the California Science Center. I hear that you are wondering about this. I thought we could start by making observations on a larger scale. Check this out. Just like the bottle, this has two liquids that we can see here. This is very similar to the bottle. Let's see what happens when I shake these two liquids up. Remember to write down things that you notice or things that you wonder. You ready? Okay, scientists, I wonder if I can guess some of the questions you wrote down. I bet you are wondering what these liquids are. Well, these liquids are ethylene glycol and mineral oil. And while those names might not mean much, you've probably come in contact with them in ways you never knew. Ethylene glycol is used to make antifreeze. Antifreeze is a liquid that helps regulate car engines during extreme temperatures. And mineral oil is an ingredient in baby lotions and cosmetics. Now that you know what these two liquids are, I'm sure I can guess your next question. Why don't they mix? That is a great question, scientists. Well, in the case of the oil and water, the oil is hydrophobic. Wait, that's a new word, but I bet I can help you break it down. Let's take a look at it. Hydrophobic. This word is made up of two parts, hydro and phobic. Hydro. Have you heard this in another word? What other words have you heard with this prefix? So this prefix hydro means water. Okay, so this word has something to do with water. Any guesses on what this word means yet? I think if we break down the second part of this word, it might make it a bit more clear. The second part is phobic. Oh, scientists, I think I've heard that in other words before. What words do you know that have phobic in it? Right, the meaning of phobic is a fear of something. Okay, so if hydro means water and phobic means scared, do you know the meaning of this word? Right, so the particles that make up the oil are scared of the ones that make up the water. This causes the two liquids to never be able to mix together. Now for our wave maker, it is a similar concept. The mineral oil is made up of particles that are insoluble in the ethylene glycol, which means the mineral oil can't dissolve into the ethylene glycol. So as hard as we might try to mix them together, the microscopic particles will never combine. They might move around each other, but they will always end up separating. Okay, I think I have time to answer one last question. I'm sure you are wondering, is this a mixture? Before I give you the answer, make a prediction in your journal. What do you think? Share with someone around you. Ready for the answer? Drum roll, scientists. This is a mixture. A mixture is a material made up of two or more substances. These two liquids make a special kind of mixture. The mixture is called an emulsion. An emulsion mixture is something that has two liquids that won't combine together. You have probably come in contact with many emulsion mixtures in your life, like salad dressing. If you leave this emulsion alone for a long period of time, it will eventually separate again. See what emulsions you can find around you. I hope I was able to answer some of your questions today, scientists. Thanks for exploring with me. Bye.
Now that we've investigated mixtures, let's take some time to explore particles that are too small to be seen. Let's make a flip book. You'll need 25 note cards or pieces of paper, a pencil or coloring pencils. I'm going to use coloring pencils so you can identify the different things that I'm drawing. The pause button won't appear in this segment, but you can pause whenever you'd like. It might also be helpful to watch this more than once. Let's get started. Let's start with our first scene. Our main character's name is Elle. Seems like Elle has noticed something on the ground, but they need to get closer to see what it is. As Elle gets closer, they realize that the red mark on the ground is a ball. Elle would love to play with it, but wonders how if the ball is flat. Now, we've been talking about mixtures and the particles that they're made of. But how do we know that some of those particles are there if they're too small to be seen? Elle realizes they might have a tool that can help. Remember, you can pause whenever you'd like. Elle has a pump. And as they bring it close, Elle wonders about how this thing actually works. Do you know how it works? Elle knows that the ball needs air. Feel free to pause at any point. Elle hasn't used a pump before, so they grab the handle thinking it might help. What do you notice is changing? I'm drawing pretty quick, so remember, you can pause or replay this part as many times as you'd like. Does anything happen to the ball when the handle is up? What about when the handle is down? Elle seems to be happy with their work. So the particles of air around us are too small for us to see. But by using this pump, we know that they are there because as we pump up and down, the small air particles fill the space inside the ball, causing the ball to expand. Can you think of another example of how we know that there are particles that are too small to be seen? Check out what these scientists made. Oh yeah, boiling water. What a great example! How does this show that there are particles too small to be seen? Share your thoughts with your class. fun experiment you can try with a plastic cup and a plate. Great thinking, scientists. The air particles will keep the water from falling out. How does this example show us that there are particles too small to be seen? Try to figure it out with your class. Hope you had fun drawing with me. Now, back to the discovery room.
What a great field trip! Let's go over all the things that we did today. We started our field trip talking about mixtures. Mariela helped us by showing us physical reactions using paint, while I showed you chemical reactions with experiments that we do here at the California Science Center. Then you practice identifying physical and chemical reactions and explaining your thinking with others. Next, we met up with Rosemary, who helped us understand why some mixtures don't mix and create emulsions. Finally, we made flip books to help us show that some particles are too small to be seen, but we can still see them in action. Now, scientists, do you remember the question of the day?
What happens when particles mix together?
Can you use the buzzword to answer the question of the day?
Mixture. Pause the video now to try to answer the question of the day using the buzzword.
Okay, scientists, it's time to count our tally marks. How many times did you hear the buzzword?
Pause the video now to count your check marks or tally marks.
And the answer is
26.
We hope you had fun on this virtual field trip at the California Science Center, and we look forward to seeing you next time. Bye.